Hi everyone, today here in this lab environment I'm going to implement here multi-area OSPF and also implement some filtering and the distribution. So I will use as we know that the OSPF use a link state advertised, I will check on the database and change the path and trying to seek the best reachability from area to area and making this working good. So let's go straight forward in this configuration for do not make this video get a little bit longer, and I expect that I can fulfill this configuration really well. Let's do it. I have here my area 1, area 0, backbone, area 2 and area 3. So first of all, let's start by the router 1. So on the area 1, I will start here by just let me increasing the console here. So it will be better this way. So this side of the network I use this configuration here. Now I use the interface method to configure it, and on the other side I use the network method, router OSPF 1, router ID. I will also implement the router ID 0001. Right, so interface gigabit 00, which is the backbone area. So IP OSPF 1 area 0. So with the area 1, gigabit 1 will be also area 0, gigabit 2, area 1, and also gigabit 3 will be area 1. That's it for now. So let's move to the router 2. Let's do the configuration, the sequence. It will be better to understand what I'm doing here. 1, 2, 3, 4, 5, 6, 7 until we finalize that. We are not gonna touch the switches here, which is the layer 3 switches. So okay, let's go to the router 2. So what I'm planning to do here on the backbone, I will use that is the area 0. I will use the interface configuration of the OSPF, and the other side, that is area 2 and area 3, I use the network config terminal router OSPF 1. So all the routers ID will be ending with his own number. So this is a good practice, but if we want to do this more challenged, we can just change the router ID, so it will become more challenged. Router ID 00, this 000.2, yes, and here will be interface gigabit 00, IP OSPF 1 area 0 and gigabit 01, and then they will format gens with the router 1, which is expected. Yes, they formatted gens. So now here I will go back to the router OSPF 1, and here on the router OSPF 1 I will say network, it will be 10.100.24.0, and then it will be mask 255.255.0 area 2, and also the network 10.100.26. As you can see here, this is 24, which is this one, 26, which will be this one, 0. And then the mask 25.0 area 2. Those are my two networks here. So for now, router 2, that's it. Router 3, all of it. Then I needed to increase the console because I'm not using a good tool here that can open all the consoles to together. There's a specific name that I forgot of the console that can gathering all together. I forgot the name of that console. Do not recognize for now. But anyway, let's continue this. Config terminal, router OSPF1, router ID 0001. No, not 001, 003. So here will be interface gigabit 00, which is the backbone, IP OSPF1 area 0, right? So area 1. So let me make sure that it's really area 1. Yes, it is area 0. So here will be gigabit 02, and then here will be area 1, and then gigabit 04, area 1, 2. So as you can see, I had the adjacent with the router 2, and now you have the adjacent with the router 1. Yes, really good. The next thing, let's keep moving. Router 3, router 4 now. Router 4 console will be here on the left side. So config terminal, router OSPF1, router ID will be 000.4. What else? Interface gigabit 00, IP OSPF1 area 0. So I had the adjacent we formed with the router 3, and then now I do go to the gigabit 01 area 0. That's it. So now I will go back to the router OSPF1. So network here will be 10.100.24.0, then 35.55.55.0, area 2, network 10.100.46.0, 25.55.55.0, area 2. That's it for now. That's it. Do show IP OSPF enable. Do show IP OSPF enable. So I have adjacent with the 3 and the 2, which is expected. So I will not have the adjacent with the number 1 because it's not directly connected. So with the router 6 I still didn't configure that so far. So I will go to the number 5 now, which is inside of the area 1. Router 1 here. No, not router 1, router 5. Giving the sequence of the configuration. Alright. Let me increase this view here. Perfect. Really good. So config terminal, router OSPF1, router ID will be 000.5. So interface gigabit 03, IP OSPF OSPF1, areas 1, gigabit 04, and then area 1, and then also gigabit 00, and then area 1. So I had the adjacent with the 1 and the 3, not yet with the 8 because I didn't configure the router 8. So let me go back to the, not go back, but keep moving forward to the router number 6 now. So this is more about a repetition. As much as we do, we are starting learning and taking the way of how it works of the OSPF. It's not easy, bro. It's not easy. Anyway, let me go back here. Router 6. Not easy to understand here this at first. OSPF. Config terminal, router OSPF 1, router ID 000.6. What else here? Network will be 10.100.26.0 and then 25.25.25.0. Area 2. Network will be 10.100.46.0, 25.25.25.0, area 2. Alright, and also the area 3. Network 10.100.67.0 and then 25.25.25.0, area 3. Alright, so I had that chance with the router 2 and the router 4, really good. So not yet with the router 7, it was not farmed yet, but let's keep moving, so he will be the next. Router 6 and the router 7 now. Router 7, okay, increase the console, let's keep moving, config terminal, router OSPF 1, router ID is 000.7, right? So interface, no, not interface. Network will be 10.100.67.0 in the master 5.5.5.0, area 3. Let's see if I have that James formatted here. I expect it. I think so. Will be formatted. Let's see. Yeah, it was formatted. So on the gigabit 01, I will put this interface gigabit 01 on the passive mode, because I don't want that keeping sending hellos. And I don't want that gigabit 01 keep sending hellos to the PC. Interface gigabit 01, IP OSPF, router OSPF 1. Passive interface, so it will be gigabit Ethernet 01. So that's it. I will do this same config here in the router 8. So I not copy, the best thing is typing, because we needed to have this in our mind and know for what we are using this. So as much as we use, it's better. So router 7, now it's a router 8, which is in the area 1. Let me go there. Config terminal, router OSPF 1. So here will be router ID 000.8. What else we are expecting to see here? Interfaces. Let's use first that we are here. Let's go and making that passive interface. Passive interface gigabit Ethernet 01. Right, interface gigabit 00, IP OSPF 1, area 1. Alright, so now that I have it all configured, so let me go on the ABR. So I have some ABRs here. Let me check here. Router 1. Do show IP. OSPF. Do show. Let me end here. I don't want to be in the interface. Show IP OSPF database. Database. Show IP OSPF database. So this is my database on the router 1. So there's another step that I want to see here. Show IP OSPF. So he has the ID. It is an ABR. This is the ABR. Let me check router 5. Router 5 probably will be ASBR. Let me make sure about that. Show IP OSPF. Where's that? Router ID. For now, just ABR is the router 1, as it was expected. Just as it was expected, that's true. Let me go back here. No, I don't want to be here. Let me check here. Show IP OSPF database. Go back here. Where's that? Here. So the router 1 has the link state advertised. Area 1 and only this. But this is the route, this is the network, and this is the summary. The summary means that router 5 area 1 can reach the other side of the network, but just until here. Just until here, area 2. Let's try to ping 5-2. Let's see this again. Okay, ping 10.146.2. Yes, but area 3, no, not yet. So okay, let me just keep moving forward. So let me go back on the router 1. On this area here, ABR, I wanted to router 1 must be the ABR. Show IP OSPF interface gigabit 03. So here, no, designated the router. Yeah, I want that the router 1 must be the designated router here. he's already the ABR, but I also want that he must be the designated router, yes. So if he was not, for somehow this configuration was not working, I would need to change the priority on the interface, and making the highest priority would win the designated, and then he would become the designated router. Between router 1 and router 2, you see, designated route, and then the backup designated router. Okay, so here I wanted that to make a router 1 the designated router, but he's already the designated router. So if he was not, I would need to change in the interface to changing the priority. What else we can make here? Okay, I will. I have some loopbacks here, and they will advertise all the loopbacks as type 5 link state advertised. So it means that in all the areas, all the routers, I will advertise them as type 5 link state advertised. Let me go back here. Config terminal, router, OSPF, redistribute, connected, redistribute, connected, subnets. When we do this command, all the OSP loopbacks will be redistributed. So I will do this command in all the routers. Router 1, router 2, enable, config terminal, router OSPF 1, redistributed, connected, subnets, router 3, router OSPF 1, redistribute, connected, subnets, yes, router 4, redistribute, connected, subnets, router 5, config terminal, router OSPF 1, redistributed, connected, subnets. What else? Router 5, router 6, redistributed, connected, subnets. Router 6, router 7, redistributed, connected, subnets. Router 8 now. Router OSPF 1, redistributed, connected, subnets. Alright, I did this in all, so now probably all the loopbacks must be advertised in all the areas as link state advertised subnets. Do show IP OSPF, do show IP route OSPF. So as it was expected, it was originated. Alright, let's make some other things here. On the router 1, do show IP OSPF interface loopback 1. Do show IP interface brief. So loopback 1 is here. It's not here. What's going on? It's not showing itself. Yeah, probably not. What's wrong? Anyway, let's change this network. Interface gigabit interface loopback 1 IP OSPF IP OSPF 1 area 0. Let's put this OSPF on the area 0, and then we are also going to change the network type IP OSPF network point to point to point. So this will change the to 32. So now if we check this again, OSPF interface. Yes, now the network type is point to point. Alright. What else we are going to work here? Let me check here. Router 6, which is in the. Let me check this network, this OSPF area. Do show ASBR. Do show IP OSPF. It is in ASBR. So yes, this is the ASBR. So in the ASBR we must use the virtual link, because if we do not, the other side of the network will not be accessible. So let me check on the router 5. We cannot go there. Do show IP. Do show IP OSPF. Do show IP route OSPF. Yes, we cannot go there. 88. Yeah, the maximum that we can go is until here. These two. We also can check this by looking at this. Do show IP OSPF database. So I have the route, the network of the route area 1, and this the summary. And then it was originated the type 5 link state advertised for all the loopbacks. let me just make this config on the router 6. Area 2, virtual link 000.2, and then the 4. We must go back there on the router 2 and 4. Area 2, virtual link 000.6. Let's see if that will be formed the adjacent. Yes, OSPF adjacent. Let me go on the router 4 now. Area 2, virtual link 000.6. Yes, the adjacent was formed now. So let me check now if I have a full router 6. Do show IP OSPF enable. So this is showing to me that now I have the virtual link. Alright, probably now this other area 1 can see this area 3. Let me go back here. On the router 5, which is not the ABR. Do show IP route OSPF. Yes, now I can see them. 67 and the 7. This one, these two networks, this one and this one here. Really good. So I will also originate Owens on the router 7. So let's use originate Owens, so whenever the other side of the network want to reach here, people. So that is the control distribution of default information we are going to use. Default information originate Owens. Okay, so now if we go back on the area 1, we can see that will be the gateway will be 000. Yeah, now has a network of 000. Good. So on this network here of the area 3, I will also implement some configuration here between 6 and 7 in case the network failing, so it will be transmitted. So first on the router 7, interface gigabit 00, IP OSPF hello interval will be 4, and IP OSPF is dead interval. In case it stopped for 14 seconds, it will be sent also notification. So let me go on the router 6, interface gigabit 00, IP OSPF hello interval 4, IP OSPF dead interval is 14. I missed the OR here. So let's see if that was from a bad GNC again. Yes, it was. Alright, really good. So let me open the PCs. PC1, PC2. This way. Show IP. PHCP /D. This way too. IP HCP /D. Alright, let's try to ping PC1 to PC2. Ping it 10.100.77.2. Alright, the ping was successfully achieved. Really good. Let's see the way that it is taking. Tracy 10.100.77.2. So let's minimize it here. So this is going to the 81, which is router 80, router 5, 35, 1, which is a router 3, and then 23, .1, 23.1, 23.1, which is this one here. What else? 26.2 is taking this away. 67 and then 77. Well, I didn't expect that it would take it this way, but let me see the reverse path. So ping and 100.88.2. Okay, Tracy, then 100.88.2. So it will go through this way. 77, router 7, 67, 26.1. 26.1. 23.2. Okay, to go and to come back, this is making the same way. So why is that happening? I have configured the OSPF, distributed them, virtual link, originated. What is happening here with this link? Router 4. show IP OSPF interface. Do show IP OSPF neighbor. Router 6 and the router 3. Let me check. Let me check to change the way here. I will increase the cost here on the router 3. Interface gigabit 01. IP OSPF. IP OSPF cost. Let's see. If that will change the way. On PC1. Try to ping. Still working. So now let me check here. 23. No, it's not anymore taking the 23. It's going to the 881. 881, it's router 8, router 5, so this is taking now the router 3, but now this one, 34, this network, 46, which is this one here, 67, and then here. Let me just go back here. Wait, let me just see this message. So let me try to ping here the PC1. The ping is working, so let's trace it to see the way. 77, that is the router 7, 67, router 6, 26, 26, 23.2, 23.2, so it's taking this away here. .35. So on the router 2 I will try to change this for the not to make this and this. Let me come on the router 2 and try to change the cost to see if this will work. I'm not sure. Config terminal, router, no, router 5 gigabit 01, IP OSPF cost 5. Let me go back on the PC. What's happening here that it was not reachable? Okay, it was reachable. Let me see what is the way. PC2 will take 7.7, router 7. 67.1, router 6, 20, router 2, 12.1. Alright, and now it changed the way to router 1. 15.2 here, 851 here, and then here. Alright, really good. So now that we notice that our traffic is to PC1, reach PC2, this is going through this way here, here, down, and then come to router 6 and then reach it here. And then to go back to PC, we'll go through this way. 6, 2, 1, 5, 8, and then reach it there. Really good. For now, really good. Let's summarize it here. We can here I have this network here, 15 and 13. I can summarize that so router 6 will not be seeing that at all, but we'll be able to ping that. So to make this, I need to configure these two routers because they are the one that are advertising them. So first will be on the router 1. Let me first see that on the router 6. Router 6. Router 6 will be able to see Dusho, IP, route, OSPF. So as you can see, router 6 can see the 13 and the 15. So let's summarize in the way that router 6 will not be seeing that anymore in the routing table, but only in the database, link state advertised. Let me check here, or even not. Let me go there. Do show IP, do show IP, OSPF, database, summary. Database. Let me check on the database. So this one is here on the summary. 13 and the 15, those are the one that I'm gonna try to summarize here. Router 1 first. Come on, let's go router 1. Oh no. Let's go, bro. Yes, this way. So router OSPF 1. So area 1 range. So I say 10.100 dot the subnet mask. The subnet will be 12, so it can be summarized here. And then what else? So here will be 255, 252.0, and then that's it. So I'll do the same command on the other side. Let me go there on the router 3. Router 3. Router OSPF 1. Area. So here will be area 1. Range. And here will be 10.100.12.0 and then 35.252.0. So those are the commands that we are summarizing this network. Let's go back on the router 6 and try to see if that network is still on the router table or even in the links summary database. So show IP OSPF route. So as you can see, it's not anymore here, the 13 and the 15, but let's try to check if it does not work or in the summary. The 13 and the 15, they are not here anymore, but the router 6 can also ping there. Do ping 10.100.15.2. It can ping that normally. Alright, really good. So there's a case here that we needed to configure. This here is that PC1 will not be able to reach the network. Let me check here. Do show IP route OSPF. So in this case, there's a suspicion that PC1 is trying to DOS a network, and this network is this one here. Let's try to use this one as an example. PC1 is trying to making DOS on this network, and for somehow we needed to block using filtering, and he distributed this for PC1 do not go in this network anymore. So let's go ahead and make this work. So for this we needed to exit for now the OSPF mode, and now go to the IP prefix list. IP prefix list, I will call this no50, and then deny. So deny what? I will deny 50. What is the network that we are trying to deny for PC1 to reach? To 50.2.6. 50.2.6.0/24. Is it 24? Yes, is it 24? 24. So IP prefix list no50 permit 0.0.0/032. That's it. So now we go in the router OSPF1, and then we're gonna distribute the list. Distribute list prefix no50 in. Alright, so PC1 will not be able to reach this network anymore. We'll show route OSPF. Do show IP route OSPF. So if now we stop to see, we are not going to see this network anymore. It's not available here anymore. So let's try to go in the PC1, not the router 1. PC1, and try to ping 50. What is the network that we did this? I need to check it here. This was 50.2.6.2. 50.6. Is that correct? No, it's not correct. It's 2.6.2. Will not be anymore available to reach this network. But as you can see, it's not possible. But if we do this command here, no distribute, which is, and then we can reach. Oh no, we cannot reach. No distribute. Maybe we do not have this network. Router 6. Will show IP interface brief. Okay, here is why we cannot reach this network, is .1. Okay, let's try .1 here. So it's possible because it's here no. But let's go now and put this in available, this command here. Right. Let's go back on the PC1 and then try again. Maybe it's still working. Why is that still working? That's still working. Will show IP route OSPF. Did they use the correct command? 52.6. Yeah, it's not available here. Do ping 52.6.1. Distributed list prefix no 50. Did they implement the correct? No 50. 52.6.0. 000 1234 1234. What's wrong in here? Should be distributed the list. Distribute list prefix no 50. So the network disappear from here, but you show IP OSPF. You show IP route OSPF. It's not showing here, but still pinging. Clear IP OSPF process. PC1, which is crazy is that PC1 still can ping there. Tracy 52.6.1 is going straight to the router 8, and the router 8 is accepting this. why router 8 you are not distributing that? No show run section. Prefix list. Why is that not working? IP prefix list in 050. It's really crazy this. To show OSPF. Well, this is here, distributed list. Deny. Why is that showing this way? Show IP route OSPF. Ping 50.2.6.1. Let's go to the router 7. No. No, redistribute. No, not this command. Let's try to say something here. Exactly. That's why now he cannot reach that network anymore. So the prefix list was working, but I was like sending this to this direction. So now PC1 cannot reach anymore that network. That's it, really good. What else now? So there's a configuration here that I would like to try, that router 5 and the router 8 should not be able to reach this network, for somehow this network here will be for some tests and they will not be available. Router 5 and the router 8 will not be allowed to reach that network, so I will configure it. Router 3 and router 1 in a way that they will not be able to reach that network anymore. For now they can see. Let me go back here. This is router 5. Do show IP route OSPF. So 46, this network is reachable, but I don't want that router 5 and 80 see this network anymore, and they not even touch this network. So for this, enable, I just go back here, config terminal, IP prefix list, IP prefix list no 46. I will call this network this way. Deny. Then 100.46.0/30, and then IP prefix list no 46 permitted 000/0/32. Any other thing else will be permitted. So for now, router OSPF 1. So area 1 future list, and then prefix no 46 in, so it will block the router 1 to all inside, and also I needed to do this too in the router 3. So I'll copy this, router 1 and the router 3. I also must make this config. Exit, post, and then here this one too, and then I will post router OSPF 1, and then the same area 1 filter list prefix 46 in, and then I will post. So I believe that for now router 5 and 8 will not be able to see this network anymore. Let's try to see that. And then 46 is not anymore here. So that's it for today. Thank you for watching, guys. I'll see you all in the next video. Bye bye.